Welcome to this brief tutorial where I am going to teach you all about working with logical operators such as AND, OR, XOR, and NOT. Just by way of brief introduction, my name is Mark Baggett. I do penetration testing and incident response consulting. I'm also a senior instructor for the SANS Institute and the author of a couple of different courses for them. One of them, SEC 573, is Automating Information Security with Python. There I'll assume that you don't know how to code, and we'll teach you how to code and how to apply the concepts of automation to the different tasks that we have in various roles in information security, from offense to forensics to defense. 673 is the logical progression of that. That is the advanced Python coding course. And there we'll teach you how to write, use, and maintain larger Python packages and different suites of tools and apply those to our daily information security routines. Of course, SEC 573 has a certification that goes with it, the GPYC Certified Python Coder certification. I'm also one of the co-authors of SEC 406, which is Linux security for information security professionals. We use Linux every day, more and more often with cloud deployments. And it's important that we know how to secure those things. So this is an introductory course. It's going to teach you how to use Linux security and how to secure your systems. I've got a master's degree in information security, DoD advisor, GSE number 15. This last thing down here at the bottom here, this is me attempting to establish some geek cred. If you grep for my name in the Metasploit framework, so if you change into your Metasploit framework directory and you grep for my name, do a word count -L to see how many times it appears. You'll see that my name appears in the Metasploit source code 7 times. Even though I've never written a module for that, it appears in there 7 times because other people have given me credit for tools that they wrote for Metasploit that were based upon concepts or tools that I've written in other languages. First, let's discuss the concept of what a logical value is. In our computers, oftentimes the results of a check of some kind will result in a logical value. For example, I might have a program check to see if an environment variable is equal to a specific value. And if it is, then it says, okay, well, that is true. And if it's not, then it considers that to be false. So that would be one example of a logical value. And in most programming languages out there, a non-zero value, so anything that's not a zero or blank or empty, is considered to be true. And those, well, the opposite of that would be that any blank values or zero values are considered to be false. Now, logic values don't necessarily just have to apply to logical tests. We can also often look at the bits that are in a byte of value and ask, well, is this bit a 1 or a 0? And if it is a 1, we would consider that to be true. And if it's a 0, we consider that to be false. In addition to our logical values, we also have logic operators. Logic operators do things with those logical values of true or false. Among the operations that we're going to be talking about here are NOT, AND, OR, and XOR. Now keep in mind, as I mentioned earlier, that these operations can be used inside of programming languages, but they can also be used inside of bytes of data. So if I wanted to select specific bits out of a byte of data or eliminate or mask out certain bits, then I could do that with these logical operators. Now, when we're dealing with bits, a 1 is considered a true and a 0 is considered false. First, let's knock out the easiest of all of these operations, the NOT operation. NOT just negates whatever value you had. So if I had a value of false, then not false would be true. If I had a value of true, then not true would be false. Now, since a 0 or 1 can be either considered true or false, if I had the value of 0, not 0 is 1. If I had a 1, not 1 is 0. Now, if you had a byte value where you had a series of bits that were made up of 1s and 0s, when you negate that, every bit that is a 1 in your byte becomes a 0. And every bit that's a 0 becomes a 1. So here 1 1 1 1 0 0 0 0 becomes 0 0 0 0 1 1 1 1. And similarly 1 1 0 0 1 1 0 0 becomes 0 0 1 1 0 0 1 1. Every place that I had a 0, the corresponding bit in the result is now a 1 and vice versa. Now let's look at an AND operation and how that might be used in the context of, say, a computer program. Our programs are often making decisions where it needs to look at multiple values at the same time. For example, if you're logging into a computer, it might ask the question, well, is the username equal to admin? And is the password equal to the correct password for the admin? Of course, it would pull those values out of databases and things like that rather than having them hard-coded like we see here. But here I'm saying is the username admin and the password ABC123, which, by the way, is a great password for all your administrator accounts out there. So here I need to do look at more than one value at the same time. So how do I do that? I can do that with a logical AND operation. Now an AND operation asks this question: is it true for both this thing and true for this thing? And if it's true for this and it's true for that, then we're going to allow some section of code to execute. So if test A was false, the username was not admin, and test B was false, the username was not password, then A and B is false, and therefore it would not execute this section of code. If the username was not admin, but the password was ABC123, then again, it would not execute that section of code. If the username was admin, but the password was not correct, it would not execute. The only time that an AND operation is going to consider this to be true is when both the first test is true, the username is admin, and the second test is true, the password is equal to the password. Then it will execute that block of code that's beneath it. Now, when we're performing bitwise operations on bytes, where we're doing an AND operation on bytes, you're taking 2 byte values and you're ANDing them together. What happens is it goes in bit by bit. So if we had a byte that was made up of 8 bits, when I AND the first byte with the second byte, it's going to ask those same ANDs and OR questions with each of the individual bits that make up that byte. So I'll go into the first bit and it'll remember a 1 is true, a 0 is false. And so here it's going to look at these bits and it's going to say 0 and 0. 0 and 0 is false and false, so the result is false. With bit 2, we have a false and a true, so our result is a 0, false. Here we have a 0 and a 0, false, 0 and 1, false, 1 and 0, 1. The only time that I'll have a 1 in my result of byte 1 and byte 2 is when I have a 1 in the bit position in both bytes. So here I've got a 1 in bit 6 and a 1 in bit 6. So my resulting AND operation of these 2 bytes of data would put a 1 in that value. Here I have another 1 here, and all of these where I don't have a 1 in both bit in the same position in both bits, it's going to end up giving me a 0 as a result. Just to give you a practical example, you use this all the time when you configure your IP address and subnet mask. That subnet mask is used with an AND operation to determine whether or not it can connect directly to an IP address or if it has to go through that default gateway that you configure in your IP settings. So let's say that my IP address, 192.168.1.50, wants to talk to 192.168.2.100. Can I connect directly to that IP address? Is it on my network, or is it on a remote network that I have to go through that default gateway? So it's got to answer that question. It's going to use that subnet mask in an AND operation in order to do that. So what I do is I take my IP address, and here I've just taken that 192.168.1.50, and I've converted it into binary for us. If you want some more information on how to convert decimal to binary, binary to decimal very easily, I've got a separate video on converting between the different bases. I'd encourage you to go take a look at that, and I'll link to that in the description. So here I've taken that IP address and just converted it to binary, and then I've taken the subnet mask of 255.255.128.0, and I've converted that into binary here. So I'm going to perform an AND operation on these two, and what this results in is, well, it shows me what the network portion of my IP address is. So now I want to communicate with 192.168.2.100. So I'll take my destination IP address. Here we have 192.168.2.100 in binary. And I'll do the same thing. I'll perform that AND operation on that address, and that gives me the network portion of that. Now, if this network portion and this network portion, if those bits are identical, so if this equals this, then that means that we are on the same subnet, and I do not have to go through that default gateway. However, if they're different, then I do have to go through this. So you're using these AND operations all the time when you're trying to figure out, well, when you're configuring that subnet mask and you're deciding which hosts you're going to force to go through the gateways and which ones you're just going to allow to communicate directly on your network. Your subnet mask that you're choosing is using an AND operation. So you'll have to understand how that AND works in order to come up with that right subnet mask. With a logical OR operation, here the result is going to be true if either test 1 is true or test 2 is true, if either of those is true. So let's say that I had a section of code that I wanted to execute if the username was student or if the username was root. For those two users, I want to do this particular section of code. For other users, I do not. Then I could put an OR statement between there. I could say if the username is student or the username is root, then perform the following actions. So in this case, this is going to execute this block of code that would go beneath here if the first, if either one of these values was true. But if test A is false and test B is false, then A or B is false. If test A is false, the username is not student, but test B is true, the username is root, well then it is going to execute, so A or B is true. If the username is student, but the username is not root, then it would execute. Or if the username was both, right? And in this particular case, a username value couldn't possibly be both. But if true or true, if both of them are true, then in that case, the result of the operation A or B would also be true, because it's asking, is this true or is this true? And it's okay if they're both true. When we're dealing with bytes and the OR operation, it's going to do the same thing. It's going to look at each bit individually, and if bit 1, or if the bit in either one of the bytes is a 1, then the resulting operation is going to be a 1. So here I have the bytes that are associated, bits that are associated with byte 1, the bits that are associated with byte 2, and if I OR these two bytes together, if I OR byte 1 with byte 2, it's going to say, all right, 0 or 0. That's a 0. 0 or 1, well, one of them is a 1, so my result here is a 1. 0 or 0, 0. 0 or 1, well, one of them is a 1, so my result is a 1. 1 or 0, there's at least one 1, so it's 0. 1, 1, here they're both 1, but the result is still a 1. 1 or 0, 1, 1, 1, 1. Okay, so any place, if this bit or the other bit is true, then the result is true. Now the XOR table, which is the exclusive OR table, is named the exclusive OR table because it actually looks at the results of the previous two tables that we just discussed, and then it asks, all right, if I do an AND operation and an OR operation, is it exclusively true for the OR operation? Is it exclusively true for OR? XOR, exclusive OR. So we have to look at the results of both tables to know what the result is. So if my first if my two values are A and B, here's my two values, here's the result of an AND operation. And this is just copy and paste from the previous two, right? True or false and false. An AND operation, that's false. False and true. For an AND operation, they must both be true. So this is going to be false, 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 true. The true there. What about the OR? Well, false or false, that's false. But all of these others, as long as there's at least one true, for an OR, false or true, true or false, true or true, the result is true. So here's my two tables. So if I want to get the result of an exclusive OR, then I have to ask, well, is this value for test A and test B, if I exclusive OR test A with test B, is it exclusively true for the OR table? And here, well, this is not true for the OR table. It's false for the OR table. So here, A XOR B is false. Here, false exclusive OR with true, that's going to be false for the AND table and true for the OR table. So this is exclusively true for the OR table. So the result here is a true. True or false? Well, it's false for AND and it's true for OR. So it is exclusively true for the OR table. So true or false is exclusively is true XORed together. How about true, true? Well, here it's true for and it's true for false. So it's not exclusively true for the OR table. It's true for both and OR. So true XOR true is going to be false because it's not exclusively true for an OR table. Now, I think what I explained to you on the previous slide about what XOR, where we get that name XOR, and the fact that it's derived from both tables is useful for remembering what it does, but that's not what I do when I'm working with XOR. I just remember that if there's a 1 and a 0, the result is a 1. But I have to have both of those, a 1 and a 0. If I have two 1s, it's a 0. It's false. If I have two 0s, it's false. So I just remember, is there a 1 and a 0? So let's just take a look at a bitwise operation on 2 bytes when we do an exclusive OR. So here's my bits for byte 1. Here's my bits for byte 2. And then I'm going to exclusive OR byte 1 with byte 2. I'll go here 0, 0. All right. I do not have a 1 and a 0, so that's a 0. 0, 1. I do have a 0 and a 1, so that's a 1. 0, 0. Nope. 0. 0, 1. 1. 1, 0. Yeah, it doesn't matter where the 1s and 0s are as long as I have both of them. This is a 1. 1, 1. Nope. I do not have a 1 and a 0. I've got two of the same value, so this is a 0. 1, 0, 1, and 1, 1, 0. Okay. So this is how we would perform an exclusive OR operation on bits. Now, you may recognize XOR as the name of an encryption scheme. And some people say that XOR isn't really an encryption scheme, it's more of an encoding. But I would say that that's incorrect. It is an encryption key because it does have data and it has a key that is applied to that data. Now, is it a good encryption algorithm? I would say it's a perfectly fine encryption algorithm. It always comes down to the management of the key. If you have a one-time pad, as we call it, which is a very long encryption, and you use it one time on an encrypted value, it works good. It comes down to the management of your keys. But generally speaking, one of the reasons that people think that exclusive OR is a weak encryption algorithm is because it is a symmetric encryption algorithm, meaning that we can use the same key to encrypt the value and decrypt the value. And if you think of this first byte 1 here as my byte of data and my byte 2 as the encryption key, then you can see that what happens is anytime you put a 1 in your encryption key, what it does is it flipped the bit that was in the data. So here my data was a 0. I had a 0, so I did not change the data. I left it as a 0. Here I had a 1 in my encryption key, so I flipped the bit in my data from a 0 to a 1. Here I had a 0 in my data key and a 0 in the data, a 0 in the key, so I left the data alone. Here I had a 0 in the data, a 1 in the key, so I flipped that 1 into a 0. Over here I had a 1 in the key and a 1 in the a 1 in the data and a 1 in the key, and so I flipped it to a 0. So anytime there's a 1 in the key, we flipped the bit back to its opposite. So now, what happens if I apply that same key and exclusive OR it again? Well, I'm going to go back in, I'm going to take those bits, I'm going to flip those same bits back to what they originally were. So this is why it's considered a symmetric encryption algorithm, because you use the same key to apply that twice. And I would say that it's not a weak encryption, but key management for most of the implementations that you see of XOR out there are using a simple, very repeatable key, which is the problem. Okay. But if we have like a stream cipher where we generate a non-trivially guessed and non-repeated string of ones and zeros, then exclusive OR is a perfectly fine encryption algorithm. All right, so I'm going to give you an opportunity to try some of this. So if you go to gist.github.com/markbaggett. So this is not the regular GitHub. Gists are where you just want to publish just small applications, not entire packages. You'll see, you might have to look around. It might not be at the top as it is now here, but you'll see that I have base practice in there. And this is a little program that you can download. We can click on this and we can download a copy of this file to our system, and this will give you an opportunity to practice with some of these different operations. So here I've got a copy of that base practice on my system, and all I have to do is I'm going to use the Python interpreter. On a Windows system, py is the Python launcher, so I'm going to launch base practice. Sorry, base practice is the name of this program. And here I can see that it's going to give me a menu of different options that we can do. So some of these are for converting from between different bases. And as I said, I'm going to use that in a separate video that I'll teach you about converting between decimal and binary. So if you're interested in that, you can go take a look at that video. But here, what we're going to do is we're going to do some logical operators. So I can go with number 9, the AND operations. Okay. And here I can see that it wants me to perform some AND operations. Over here, you got a score. You got to get 5 to complete this exercise, and you get 2 mistakes before it will assess some penalty to you, and that penalty will change. But here, so I want to do an AND operation. So I put a 0B. Here we have a 1 and a 1, so the result is a 1. A 1 and a 0, nope, that is not, for an AND operation, both must be a 1. So any place that I don't have a 1, I'll put that in there. You can see that I got that correct. So I'll do another AND operation. Again, any place that I see a 1, I'll put a 1 or 2 1s. And any place that I have something other than that, I will put a 0. So here I do not have 2 1s, do not have 2 1s. None of those are 2 1s except for that one. And here's 0B. Oh, there's 2 1s, 2 1s, not 2 1s. Here's 2 1s, not 2 1s. 0B. Not 2 1s, not 2 1s. There's 2 1s. Okay. And there I got through that operation. Okay, I also have some OR operations, some exclusive OR operations, some not operations, not and operations. And we can also do some random ones. So let's do some random ones here. I'll pick 15. And here I can see that it's asking me, this is the exclusive OR operator. You can see that here from the menu, that an AND operation is symbolized by an ampersand, pipe for an OR, and a caret for exclusive OR. So here I've got to do a not exclusive OR. So I got to do a couple of things in my head in order to get this one right. So this one, first thing I have to do is take everything that's a 1 here and convert it to a 0 so that, well, that's the not operation. Then I can do the exclusive OR. All right, so this is actually the first bits. If I take a look at this first bit here, 1 exclusive OR with a 1, right? Because I'm going to negate that bit. So 1 or 1, that's going to be a 0. Actually, let's start over on this side. I'll just do my 0B. And then this is going to be a 0 exclusive OR with 0. So that's going to be 0. This is going to be a 0 exclusive OR with a 1. So that is a 1 and a 0. We have that combination. So that'll give me the 1. This is going to be a 1 exclusive OR with 0. So that's going to be a 1. It's going to be a 0 exclusive OR with a 0. So that's a 0. And all of these are the same, and that means these are all going to become ones. So this is going to be one exclusive word with ones. Those are all zeros. Okay, so we'll get that one right. Oh my goodness, another exclusive or not. I think this is probably the hardest of all of these, is going to be the exclusive or with the not, because you got to do two things in your head, right? Okay, but let's do this one. 0 exclusive word 0. So that's going to be 0 be 0. This is going to be a 1 exclusive word with a 0. So that's going to be a 1. This is also going to be a 1. That's going to be a 0, 0, 0, 1, 1. And you can see that I have 18 more of those to go. All right, so I won't go through all of those here, but you can see how you can perform these labs. I'm going to hit Control-C to get out of this. I could run it again, just go in here and do a simple OR operation by selecting 10 from the menu, 0B OR, so that's going to be a 0, 1, 0, oh no, or 1, I was doing exclusive ORs. So if either one of those is 1 for an OR, the only thing that is going to be a 0 is when I have these two zeros here. So that's going to be a 1, 1, 1, 1, 0, 1, 1, 1. 0B, 1, 1, 1, 1, 1, 1, 1, 0. Ooh, I put a 0V. I got that one incorrect. Oh well. All right, so that's your OR operation. So there, you've got these practice labs you can work through and get used to doing some of these logical operations. If you're interested in some of these other labs, as I mentioned, I'll put together a video on how to convert between different bases as well. All right, that's all I have for you in this video. I hope you found that to be useful. You can follow me on Twitter at Mark Baggett. You can email me, mbaggett@sans.org. And here I provide you some links to my different courses if you'd like to come spend some time with me and learn how to do some awesome things in Python or how to secure your Linux operating systems.